Sir, thanks for joining us today on Leadership Log, which is a podcast for the Air Force Lifecycle Management Center community on topics of interest. And the topic of interest today is learning more about the B-1. So we're here with Lieutenant Colonel Glay, and he is the program manager for the B-1 program office at Tinker. Is that correct, sir?
That's correct. Yes, sir.
Okay. Sir, if you could just introduce yourself a little bit and give us some of your career background.
Great. First, thanks for giving me this opportunity to talk about the B-1 and the great things that we're doing in the program office. As you mentioned, my name is Lieutenant Colonel Joseph Glay. I'm a material leader here at Tinker Air Force Base for the B-1 program office. I am the branch chief for systems engineering. A little bit about my background and my history. I've been in the Air Force for 17 years. I did 4 years as an intelligence officer, but the rest of the time has been in acquisitions. I've done a little bit of research and development, a little bit of now sustainment. So I've kind of seen all the spectrums that we do in acquisitions.
Mm-hmm. So it's been about a year ago that B-1, it's 850092, was pulled out of the boneyard and was trucked to Wichita State University to become a digital model. So if you could give us a little background on where exactly it went in Wichita and what's the status of it right now?
Sure. First, there's some great pictures out there of seeing a B-1 towed from Arizona out to Kansas and taking up 3 lanes of a highway. So if you Google search it, there's some cool pictures out there, especially going through some small towns. But simple answer for you is we needed to figure out a way to do things smarter, cheaper, and better, right? That holy trinity that's always out there for acquisitions that we're trying to achieve. For the B-1 specifically, repairs were just taking too long to develop. Sources of manufacturing were harder to find, especially for parts, right? We're a legacy aircraft. We were developed back in the 80s. And so your original source of supply doesn't exist anymore. So try to find somebody that can manufacture some of those parts that didn't exist. So we had a backlog also of projects where we had to do analysis. And so we were trying to figure out how can we do this better? And the term digital engineering started to creep up, and NIAR provided this opportunity. And we said, yeah, let's do this. We think this is a good opportunity for us. So in addition, there was a number of inspections and repairs that were negatively impacting the fleet at the time and mission readiness. And that was a big thing for us, right? Is can we make the fleet better? So with digital engineering, we had that opportunity to be more proactive and predictive in what we were doing and getting better at our maintenance. Today, we're very reactive. Tomorrow, we want to be proactive. Mm-hmm. Being reactive means we wait for something to happen and then we try to figure out what to do. We don't want to be in that position. We want to be where we understand what's going to happen. We already have the repair on the shelf and we go out and put it on the aircraft ahead of time so that we keep that aircraft availability very high, especially with a smaller fleet. That's very important.
Yeah, limited resources, you got to keep them flying, right?
That's right.
Okay. And you said NIAR. Now, that's the National Institute of Aviation Research at Wichita State University, correct?
That is correct. Yeah, thank you for that.
Okay, all right. So tell us what all we hope to achieve with this digital twin.
Sure. I like to think of a digital twin as a kind of a digital medical record. That's kind of my simple thought process behind it. Where each aircraft now has a digital medical record, and we can pull those all together. And then what you can do is you can assess the health of your fleet ahead of time. Like I mentioned earlier, you can be more predictive and proactive in your maintenance. Where right now, we're in that reactive state. This will allow us to decrease our repair times and get aircraft back to flying a little bit quicker. Which is our ultimate goal there, is to increase reliability, increase maintainability, and increase then aircraft availability.
Okay. And so how do you do this? I mean, how do you create this digital twin, and how's it progressing?
Sure. That's a great question. Really for us, our work is being completed in multiple phases that are kind of being done simultaneous. So first, there's the part where the mechanics are actually going out and they're taking parts off the aircraft. Those parts are then scanned using a laser scanner, and that creates a 3D image of that part. Simultaneous, we have engineers that are taking the old 2D drawings and they're converting those into 3D drawings. And then we do a side-by-side comparison to look for differences. And that's actually one of the biggest benefits. A lot of these aircraft were kind of hand-built, right? There's the as designed on a piece of paper, and then when the mechanic gets out there, he might drill a little bit different, or the parts might not line up, so they add a little shim here or there. So we can actually, going back to that medical record, say, hey, you know, this is how it was supposed to be, but this is how it really is. Each aircraft's unique and different, and we can start to capture those differences. So while that is going on, and now we've kind of compared the differences and we understand, once we have those models built, we're also developing the loads, the external and internal loads of the aircraft. As we start to pull that data in, now I can run simulations. And that's where I can become predictive in nature. I can now say, hey, I want to do a test case. I want to see what's going to happen to the wing if I do X. And X could be if I fly faster, or I fly higher, or I do a high G turn. Oh, hey, that part breaks. And now I can design the repair. I can put the repair in virtually, and I can run another simulation. Did the repair work? Oh, yeah, the repair worked, or it didn't. And I can go back and I can, again, make a repair virtually, put it in the aircraft virtually, and test it. That's going to save us money and time, which is a huge benefit for us.
Yeah, so I mean, I could see that in some instances you make a part, you don't know for sure that it's even going to fit, but with this you can test it and make sure and know definitively that it's going to fit before you even put it in there.
That's right. We can do first-time fit checks in a virtual environment because we have everything modeled down to the thousandths of an inch. So you can make that part virtually. You can actually put on Oculus goggles and get into a virtual environment, and you can practice installing that part and say, yeah, that part is going to fit the first time before I go to manufacturing. We've had a couple instances currently where using legacy 2D drawings, and we've given it to a manufacturer. They don't understand how to read those 2D drawings. And so you get a part back that's slightly different and it doesn't fit. And so now you're stuck, right? You have to go back to manufacturing. You got to try to get the part again. You have to understand why they couldn't read the drawings, what created that difference. We hope to eliminate a lot of that by now having 3D drawings of all of our parts that we can go right out to manufacturing with. Another good part here is that we are currently ahead of schedule on this project and under budget, which is not something you often get to say about acquisition projects as a whole. So this is a very big plus for the B-1.
So what practical results have you seen so far?
Another great question. So we've seen a couple small practical results. We expect to see greater results as the project continues. For example, we've been able to provide 3D drawings to manufacturers, the example I just talked about. And that's very helpful as manufacturers these days are not very familiar with 2D drawings, as I mentioned. So being able to have 3D drawings has expanded our manufacturing base. So we were able to go out and get some parts a little quicker than we have in the past, where we used to get a lot of no bids because manufacturers couldn't understand the 2D drawings. So that's been very helpful. We were also able to take our 3D model that we have and use it to put our data points against where we were tracking current issues that we have on the aircraft. So we were able to create like a heat map of all of the issues that we have on the aircraft. That allows us to run analytics to say, hey, why are we having more issues in this area than over on this area? Is there a relationship between those? So we've seen those small benefits at this point, and we hope to get more benefits as we gain those external and internal loads, and we have more models and we can run our own simulations.
So you said it expands your OEM, so that increases your competition. I would imagine ultimately can save you some money as well, correct?
That is correct. Yes, once you can open up that industrial base, that'll help decrease our costs. like you said.
Yeah. So do you think that the biggest impact is going to be in sustainment, like corrosion control and things like that in future upgrades, or?
So actually, I think the biggest impact will be wherever we want it to be. Digital twin is kind of like a stepping stone for many firsts. It's kind of like a choose your own adventure, and you can take it wherever you want to go. We initially saw the benefit on the structure side, and I think that'll lend itself more to sustainment, helping us with those repairs, fleet safety analysis, and predictive analytics. However, we just awarded a new contract to the National Institute for Aviation Research, or NIAR, as we talked about earlier, that allows us to branch off into many other areas, including flight systems, weapons integration, avionics, so that we can look at other areas and explore the capabilities of DE in those environments, in those areas too. So we're really excited about that. With this new contract, we'll be able to do digital upgrades. We'll develop our own system models. We'll convert TOs, paper TOs to digital documents that'll be linked through a digital thread to the models that we're creating and to our simulations, so that everything is tied together. So at this point, we're kind of expanding our horizons on the B-1 for what we can do digitally.
Mm-hmm. So what do you see on the horizon for the B-1? Are there any other major upgrades or improvements that you've got planned?
Yes, sir. So the B-1 has a major fuselage repair upcoming in 2025. 17 aircraft require a 20-foot long by 6-foot wide by 4-foot deep section of the upper fuselage to be replaced and repaired. This is a very large and complex repair. It's about 14,000 parts if you include all the fasteners. Wow. With some really large and expensive skin panels and dorsal longerons. And we've used some digital engineering already to help us with this project, modeling the area, making sure we get those first time fits on some of the components, and allowing us to find other industrial partners that can actually make these components. Further, the B-1 has some other upgrades coming to its radio and flight control systems. We're hoping to use DE, or digital engineering, to help with the flight controls project as it comes on board. So that's kind of where the B-1 is today and where it's going to be going here in the future.
Okay, all right. So sir, that kind of gets us towards the end of our time. But before we go, I just want to see, is there anything that that I forgot to ask you about, or anything that you'd like to add?
Sure. I think the B-1 is kind of proving that even legacy aircraft can do digital engineering and see some kind of benefit. There's a lot of new Air Force platforms that are being born digital. And I think that's the easy way, because you plug in right away. That when you're deep in sustainment, it's harder to understand what benefit digital engineering can actually provide. And I think what we did at B-1 was we stepped back and said, hey, what's really hurting us right now? And we said, hey, that's structures. What can digital engineering do to help us with structures? And once we found a good partner in NIAR, and they kind of opened our eyes and said, hey, there's some benefit here. You can kind of do X, Y, and Z, and this is the benefits you'll see with being able to model parts, and then, the industrial base, and, virtually test fit things. We said, wow, this is something we can actually do and see some benefit here deep in sustainment. And that's where we started. And now that we've kind of gotten started with digital engineering, I think we've really bitten off on it. And the award of the new contract I was just talking about, it shows that we're kind of finding other little areas that we can find benefit from digital engineering. So we're really excited, and we're moving in that direction. So predicting issues and predictive analytics, like we talked about, is big, especially for a small size fleet. And digital engineering will help us then be more predictive, more proactive in our maintenance and our management, keeping that aircraft availability high and helping out with the warfighter. So I think that's a good lesson learned for everybody to understand, is that any program office, no matter if you're starting or you're deep in sustainment, can find a benefit. You don't have to go full in. You can kind of bite off a little chunk. it's also all about understanding, what you want to do with that digital engineering then. Like I had mentioned, we found structures first and then it expanded. So DE is a journey, and you got to just take it a step at a time. We're still learning in the B-1 office. At the same time, we're making the platform better. We're also making our workforce better. Our workforce is learning what digital engineering means. They're learning to speak, write, and kind of execute in the digital environment. And then our partnership that we formed with NIAR is building the next workforce to come on board. All those students that are working at the university are getting hands-on experience on DoD equipment, as well as they're learning how to write and speak and execute in digital engineering environments. So it's a very big win across the board for both our office and our workforce and the future workforce that's coming right behind them.
So it sounds like, I mean, right now, the creation process is kind of painstaking to go through and scanning these parts and interpreting the designs and everything. But in the back end, the payoff is potentially huge.
I wouldn't say it's totally painstaking. It's maybe laborious
Mhm.
to do. But yes, the payoff is really big. And that's what we're looking forward to. And like I said, you get little benefits here and there. You scan a component and you realize that's a component that just broke. And so now I can go out and purchase it a little bit quicker. But the payoff in the back end, once I have a full model and I can run my own simulations and I can be predictive in nature, is going to be very beneficial to the B-1 office.
Right. So, sir, thanks for joining us today on Leadership Log. We really appreciate you helping us understand better what's going on with the B-1 and digital engineering.
Yes, sir. I really appreciate the opportunity to highlight the B-1's efforts and what's going on down here at Tinker Air Force Base. Thank you very much, sir.
Thank you.